Hello everyone, welcome to this video where we are going to explore the length of a line segment. So for this particular question, I'm going to look at 2 points, given 2 points, x1, y1 and x2, y2, point A, point B. What will be the length? And sometimes we refer the length as distance. Okay, so this is the formula, and I'm going to prove by Pythagoras theorem how this formula comes about. So I am going to show that this line, this red color line here, is indeed x2 minus x1, because my point A will be x1, y1, point B is x2, y2, meaning that if I were to draw a dotted line down here, and therefore the distance here all the way to this point, this distance, this black color distance will be x2. Using the same idea, so the distance here would be my x1, and therefore to get the red color distance, it has to be my x2 minus x1. Okay, and using the same idea, I am going to look at my distance here. So I already have the distance from here all the way down is my y2. So the distance from here to here will be y1 and therefore the distance for the blue color will be my y2 minus y1. Now that I've got the length, right, I am going to just replicate this triangle and draw here. And you can then see that given this right angle triangle, I have y2 minus y1 here. I have x2 minus x1 here. And how do I find this length? Yep. By Pythagoras theorem, the length AB is therefore equals to AB square is equals to x2 minus x1 square plus y2 minus y1 square, and therefore to find the length AB, I just need to square root this whole thing, which is how the formula comes about. Alright, so I've successfully proven this formula. So just to illustrate, this is my red color line, this is my blue color line, and this is my black color line. Alright, the next few examples I will share with you how then we can tap on this formula to solve problems. Hello everyone, for this part of the problem, we are required to find the length of the line segment MN, and this is what Mr. Tan would write. I will have my x1, y1, x2 and y2, And knowing that the formula for the equation of the line is square root of x2 minus x1 bracket square plus y2 minus y1 bracket square, then it is very easy for us to do because we now are able to just substitute neatly the values for my x1, y1, x2, y2. Alright, so it will be 3 minus, if it is negative, I will have to put a bracket, square plus 7 minus 5. After which, I just need to press my calculator and I will get my answer as 4.4721, about 5 to 6 significant figures followed by 3 significant figure, 4.47 units to 3SF. Alright, and we are done with this question. Let's move on to the next example. Hello everyone, welcome to this example where we are required to first, for part A, find the length of the 3 lines given the coordinates. So I'm going to make use of the formula which I'm going to write out here. So the length is equals to the square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, so for part A, and I usually like to color code them to make it easier for me to see. So for PQ, my working goes like this: the square root of bracket 3 minus negative 3 square plus 2 minus 0 square, and this will give me the square root of 40, and square root of 40 would then lead us to 6.32 units to 3SF. We shall continue for QR. Again, I'm going to color code R as green color, and you will then see my working. I will have 4 minus 3 bracket square plus negative 1 minus my 2 bracket square. This will give me square root 10, which is equals to 3.16 units to 3SF. Okay, let's move on to part the next line. Okay, PR. Going to repeat this whole thing again. P and R, so I will have my 4 minus my negative 3 square plus negative 1 minus 0 square, and this will give me a value of square root 50. which is equals to 7.07 units to 3SF. Okay, part A is done. Now, for part B, we do have to show that PQR is a right angle triangle. And to do that, I saw that if I look at their values, I saw that PR square is equals to square root 50 square. This one is equals to 50. I also saw that PQ square plus QR square is square root 40 square plus square root 10 square also give me the same 50. And since PQ square plus QR square is equals to PR square, by the converse of Pythagoras theorem, triangle PQR is a right angle triangle. And once I know that this is a right angle triangle with PR as the longest side, I would then be able to find the area of a triangle easily by, let me just have one more space as I go to this side. And I'm going to just draw this sketch. Longest side will be 50, square root 50, sorry. So if this is P and R and Q, PQ would then be square root 40, square root 10, not drawn to scale. And with this, I would then be able to find the area of this triangle, PQR, simply half times base times height. So that the final answer would be 10 units square. And we are done with this example. So let's move on to the next example. Hello everyone, welcome to this problem where we are given point C as 3, 2 in the diagram here. And point D is somewhere along y-axis such that the length of CD is 5 units. So given that it is on the y-axis would mean that the x coordinate is always 0. So I'm going to let D be x is 0, but y we don't know, so I'm going to write as y. And once I have this, I would then be able to apply the formula to find the length, since we know the length is 5 units. So I'm going to apply the formula now. Meaning my square root of 0 minus 3 bracket square plus my y minus 2 bracket square is equals to 5. And I'm going to slowly simplify inside first. This will be 9 plus y minus 2 square. And if I do not want the square root, I square both sides. So I'm going to solve this particular equation now. So y minus 2 bracket square is equals to 25 minus 9 on both sides. And that will give me 16. And do take note, why is there possible coordinates? It's actually because every time we square root something, there are two possible answers. So find y minus 2 is equals to the square root of positive or negative 16. And therefore, there are two possible answers. Y minus 2 is equals to positive 4. And I will get the first possible answer is 6. Or y minus 2 is equals to negative 4. I'm going to plus 2 on both sides. And that will be my second possible answer. So the final answer would then be, let me just make sure that I got some space. Do indicate your final answer as such. Okay, since they ask for coordinates, it's either 0, 6 or 0, negative 2. With that, we have come to the end of this question. And at this point, if you like this video, do give it a thumbs up. And thank you very much for watching. Hello everyone. For this particular question, we are supposed to find all possible coordinates of point S where, they give us 3 points labeled nicely for us. P is here, Q is here, R is here. And we need to form a parallelogram. Parallelogram. So all possible coordinates. For this video, this video will be for the first possible coordinates. So let's do a quick one. So from here, if I were to try and form a parallelogram, this is one way. So actually I could just draw nicely and neatly, and because this is just drawing, it may or may not be a negative 4. I just estimate, but I won't know whether it is really negative 4. We have to show working, some form of working to show that. So my S, I will let it be A. X I don't know, but Y I know for sure. Because in this case, if you look at it, it is a horizontal line. So therefore the horizontal line is here. The Y value has to be, yes, 0. So of course, in your working, do take note. Please let the marker know. Let S, let S be a 0. Full stop. Next, how do I get my A? It is important that you know that the side, the length of the opposite sides are the same. Therefore, I would like to check how many units this length would be. From here to here, from 0 to 2, there's 2 units here. From here to here, from 0 to negative 6, there is 6 units. So now I know PQ equals to 8 units. If PQ is 8 units, SR must also be equals to 8 units, parallelogram. And I already know from 0 to 4. 4 units here. So I now know here to here must be, yeah, I know your mental sum very good but still must show working so must show that 8 minus 4 equals to 4 units. So therefore S, the coordinates for S would be -4, 0. This will be one of the possible answer. For my next video, I will show you the second and the third possible coordinates of point S. Eh呀，我没有录，我没有录，我没有录，气死人了。要录哎呦Okay, in this particular question, we are supposed to find all possible coordinates of point S, P, Q, and R is given, such that these 4 points P, Q, R, and S can form a parallelogram. In the other 2 videos, 2 possible coordinates have already been shown, so this will be for another way, another possible way to form a parallelogram. So, if you look carefully, this one will be quite difficult to visualize. I'm going to draw and connect this and connect this as well. There I see. I hope you guys can realize that another way to form this will be in this format. It's okay lah, yeah, you know, so it should be somewhere here. Ayo. So I shall call this point B. X coordinate I don't know, but I know the Y coordinate horizontal line, ta 0. So I'm going to let S be let S be 0. And again, a parallelogram, the opposite sides, the length is the same. So step 1, I would want to know what is my PQ length here. From 0 to 2, here is 2 units. From 0 to -6 is 6 units. So PQ equals to 6 plus 2, 8 units. That means RS must also be 8 units in order for this to be a parallelogram. So from 4, I need to make sure that here, this whole thing is 8 units. 4 plus 8 lah. Yeah, must show working So now I know B is, at this point here, should be 12. Therefore, S is 12, 0. This is another possible value of S. The other two possible values of S, please refer to the other two videos. Hello everyone, this is Mr. Ryan Tan. So here we have this question. There are altogether quite a number of few possible coordinates of point S. Two other videos have shown to you two other possible coordinates already. So this one will be a third, another possible coordinates. So in order to form a parallelogram, so I'm going to connect these two lines and this line. So if you guys can see that, another possible coordinate. So as you can see, this is not drawn to scale. I agak one. So point S, I won't know what it is. And this one, I don't even know what is the X and Y X value. So I shall call it X, Y. Okay. So from here, let S be X, Y. In a parallelogram, do take note. Since the length is the same, that means from here to here and here to here is the same. That means here, this is very important. Notice how I'm going to do things. From R to Q, I'm going to count how many units are from 0 to 4 units up. How many units to the left? From 4 to 2. 2 units to the left. That means for my point P to my point S, it must also go how many units up? Yes, same thing. 4 units up. How many units to the left? Very good. 2 units to the left. Then I can solve this pretty easily, because in order to get this Y value, my Y will be equals to, from 4, I move 4 units up. So 4, I move 4 units up, plus 4, I get my Y. And for my S, the X value, initially is at -6. Now cannot anyhow plus already. Why? If I move 2 units to the left, every time I move 2 units to the left, another 2 units to the left, what do you think it should be? From -6, 2 units to the left. Yes, X should be -8. And therefore, my S will be -8, 8.